All right, so in this lesson, 5.9, we are going to graph. So we take a break from solving. So far, we've been solving polynomials in the back half of chapter 5. Now we're going to graph. And we're just going to transform the parent function like we've done many, many times before. So kind of review of this is if you had x squared, that polynomial graph looks like that. And then we talked about like some basics where like if we were to take that function, see if I can get a different color here, and like just like slap a +4 on the end, all that does is as the same parent shape but just goes up 4 from where it was before. I think that's only 3, sorry about that. So you go up 4 and then draw the same type of parent shape as the one you had before. Okay, and we did this with a lot of different functions. So like maybe you remember absolute value of x, which is this V shape, looks like this. And then, if we just put like, say, I don't know, like a 2 in front of it, that's going to stretch. The times 2 will just make it stretch and go up faster than it would before. So that one didn't get shifted left or right or anything, but just multiply by 2 made it like a steeper slope, which is sometimes we call a stretch by 2. Okay, and so all that's different is we have a different parent shape this time. We have the cube shape. Right, so the first thing I'm going to have you get down in your note is what does the basic one look like? So if you want to do y equals x cubed, draw that in your notes. And then see if you can remember all these different transformations. How are these different than that base starting one here? All right, so pause the video, try these if you haven't already. So a +5 on the end will make us go up 5. If it's a plus or minus inside that goes left or right, opposite of what we think. So this one should actually go to the right too. So it'd be the same shape, but just to the right too. And I can't draw this. Sorry, my little pad. I'm going to use Desmos here in a second, but it'd be that same shape, just right too. This one is inside again, so left or right, opposite of what we think. So +7 actually goes left 7. The 4 in front is going to be a stretch by 4. And I should say vertical. This is like a vertical. So when we stretch or compress, it's always in the vertical sense. You got to imagine pulling it vertically so it'll go up faster than it did before. Okay, and then if the number is between 0 and 1, that's going to be a vertical compression. Okay, and we say by factor 1/4, because we're multiplying a fourth. So multiply divide is either stretch or compress, depending on how big the number is in front. And so again, because I can't graph great in here, and this is a really good way to learn. So I use Desmos a lot. So what I mean by that is if you load up Desmos and just graph the basic x cubed, right, you get that shape there. I can make it show up a little bit better, right? But then maybe I can't remember, like I could put the y in here too if you want. Maybe I can't remember what happens if you put a +7 on the inside, right? So +7 like that, and then I'm going to do to the third power. Right, maybe I can't remember what happened. So if I graph it, I can see, oh hey, I couldn't remember if it was left or right, but it looks like this one goes left 7. Right? So again, maybe I can't remember what happens like if I put a fraction here. So you just do it. Do 1 divided by 3, maybe even a bigger number, 7, and you can see it kind of smushes it out. Right? And oftentimes I'll graph the original one there too. So maybe I'll get that one up in green. So you can see how the red one, the 1/7 smushed it, right? Smushed it in the vertical sense, right? So playing around on Desmos is super useful if you can't remember, right? And I'm gonna turn these off and go back, and then maybe like how do you make it reflect? Maybe you can't remember that. So again, the reflect is you put a negative in front, right? And you can see that flips it. And kind of interestingly on this negative both flips it over the x or the y-axis. You could interpret it either way. So I'll go back and put the original one on there. So you could imagine flipping the blue one over the y-axis for sure and getting the green one. Or you can imagine flipping it over the x, right? So that's kind of goofy. And so with the example I'm going to do, I'm going to shift it first a little bit and then do the transformation. right? So the next thing maybe we'll do in notes is the reflection part. And so this is kind of the key. If you want to go over the x-axis, you take the whole thing times -1. And if you want to reflect over the y-axis, you multiply only the x part by -1. And so we're going to do a couple examples here if you want to make a little chart in your notes. Okay, so hopefully you can draw this little chart out. Pause the video if you need. So to do over the x, you're going to do the whole thing times -1. So I'm going to put a -1 in front. So it would look like this. -1 times x plus 2 cubed. So this one would go reflect over the x-axis and then go left 2. Okay, and then if you want to go over the y-axis, you put the negative part inside with x, and then you still have the cube here. Okay, and putting it there will make it reflect over the y-axis. So this one will go left 2 and then go over the y. And again, to show you this, the best thing I can do is do Desmos. So I'm going to clear out some of these other ones here. We're going to do the x plus 2. And we're going to put the cube on the outside. Okay, and so that one, like we would expect, goes to the left 2. Okay, and then if I put the negative, that's going to flip me over the x-axis. So you can see when I put the negative in front there, whoops, right, that flips me over the x-axis. Right, so now to do the y-axis, I'm going to put the negative inside, and that'll actually flip this point over across here. So if I put it on the inside, you can see it flip across the y-axis there. So it actually goes left first and then flips when I put the negative. So it goes left 2, sorry, and then flip over. Right? So you try it on the second one, make sure you got this all figured out. Let's see if I can find an orangish pen. So on this one, for x again, you put the -1 on the outside, so that this one would go right 4 and then be flipped over the x. And then this one, if we put the -1 on the inside, that'll make it go, sorry about the poor handwriting there, that's a parenthesis. But this one will actually go right 4 and then get flipped back to the other side. So it'll look like it actually went left 4, but technically went right 4 and then flipped over the y-axis. All right, hopefully that part made sense. Okay, and again, if anything doesn't here, I use Desmos to verify. Sometimes, especially when I was first learning this, I wasn't really sure, and so I was like, just do it in Desmos, and that usually helps me figure it out. All right, so next is we have to take the parent and then apply these transformations. And so again, I encourage you to pause it and see if you can figure this out without my help, and then on pause to check your answer. What I usually do here is I just fill in the blanks. So I make like a little setup like this with blanks, and then say like this number in here is my left or right number, this is my up or down, and then stretch, compress, or reflect would be the number out front. So when it says stretch by 2, I'm just going to put the times 2 in front. When it says down 5, I'm going to put a -5 in the back, and left 3 instead of -3 would actually be +3 on the inside, right? And that would be our function that transforms based on these set of commands. All right, let's have you try another example here. Okay, so here's my setup again. I'm going to leave space for number out front, put the cube here, leave a space here, no space there. So I've got to go up 6. So I need a +6. Right forward would be a -4 in here. And then reflect across the x-axis, I got to think -1 on the inside or the front. And so here you got to take the whole parenthesis part times -1, and that'll make it go over the x-axis. Okay, and again, if we're not sure, we could graph this and see if it actually meets those transformations. All right, last one for you to try. A whole bunch of stuff on this one. I'm awkwardly pausing here because I want you to do it before check your answer. All right, stretch is going to be multiplied, so I'm going to, actually that's an error. That should be a compress because we're something between 0 and 1. So that'd actually make it compress. I don't know what the author of this question was doing here. That should be a compress by 1/2. We factor across the y-axis, you're going to have a negative on the inside part there. Down 5, minus 5, and left 2 would be a plus 2 inside there. That would make us go left 2. All right, I believe that's it. So pretty much a review because we've done this so many times, and all that's different on this one, again, is our parent shape is different, our cube shape, which looks like this. Okay, so if we need to graph it, we can just transform it, right? Use the different transformations and graph it that way. All right, that's it. Thanks for watching.